about stars. Stars are giant balls of gas in outer space. They are so big, and they have an action called confusion or nuclear fusion. They constantly confuse hydrogen to helium, and that thing makes up their power and photons in them that can go on through and form, and give out heat, light, and that's what makes stars luminous. Without the confusion in their core and the nuclear fusion, there's nothing they can do. Well, let me give you some examples of stars. Our sun and some other stars like UV, Scuti, Sirius A, and stars are really important because they're some of the most important things for finding your way when you're lost. I'll talk about this on the future episodes and you can understand why I'm saying this. Now I'm gonna tell you about types of stars. The most abundant types of stars in the universe are red giants. Red dwarfs. Why? Red dwarfs are small, really teeny tiny compared to other stars. Well, actually, red dwarfs, some of them can be so small that our sun can be 12 times bigger than them. A lot of times bigger than them, let's say. Like some of them can be the size of Jupiter, and some of them can be 100 times bigger than Jupiter. And because they're so small, they really use less gas than other stars. That's why they live longer. The less gas they use, the less they'll live. And the more they will live, like they can give trillions of years, and that's why that when every star in the universe explodes up and nothing will be remaining in the universe, the red dwarf will be the last to survive on the universe. Well, the next type of star is a yellow dwarf. It's the exact type of our sun. Our sun is actually a type of a bigger than a red giant. Let me tell you this, that the colder the star be, the redder. Look, let me tell you that the more red the star be, the colder it is. And the bluer it is, the hotter it is. And this is really impressive. Like, if I'm gonna explain a red giant in this episode. And a red giant, we call it red giant, and it's red. And as I said, it breaks the rule of physics if it's rule of star forming and the stars if it's be hotter than a blue giant. Well, a red giant can be really cold. Why? Because it's red. It's red, just like red dwarfs. While big blues can be even hotter than red giants, because as I said, the rules of star, thing is that for the star to be blue to be hotter, and for red to be colder, and that's why red giant is colder. And also that stars, these yellow dwarfs, they are big but not big as we think. They're stars that are more giant than our sun, and our sun only lives 10 billion years. Why is that? Because it's bigger, so it uses more fuel. Stars like blue giants and red giants will just live millions of years, and blue giants can just live 2 billion years somehow because they're really big. Okay, now let me tell you about our sun compared to other stars. Stars are giant in outer space. Well, without stars, we wouldn't have had abundant, sky like this we have today. Stars are making our sky view beautifully and really gracious and all the stuff. Well, actually, our sun is just an average star compared to other suns. Our sun is just one star of billions of yellow dwarfs in the universe. And it's just one star of millions of trillions of billions of stars in the universe. That's a lot of stars. And that's what we have actually, starry night, we call it. Yeah, really I enjoy it. If I were in a place that there wasn't any light pollution. Now, let me tell you about how, the life cycle of our star, the circle of life of our sun. Our sun is actually a star, as I said earlier in this episode. Well, Our sun can die really badly. It can eat some of its 9 planets. Well, actually, if you delete Pluto, we have 8 planets because Pluto is not counted as a planet. Anyway, it will eat 2 of those planets when it's gonna die. As I said, it will live 10 billion years. And our sun had already passed 5 billion years of its life. And we don't have much more time. Like, 5 billion years, that's a lot, but not for a star. Like, it's just 5 years for a star. It started to get bigger and a little bit hotter. Then the iron forms in it, and then that iron will totally destroy the star. It will get bigger, a red giant as I said, and it will get smaller again into a yellow teeny tiny white dwarf, and then form a beautiful planetary nebula. Just like M21 or M29 anyway. There are a lot of planetary nebulas in our sky, but we actually sometimes see them as stars. Well, actually, because they're far away, we can't see them as stars in our night sky. Anyway, our sun can turn into a red giant. It can eat Mercury and Venus, and some even say it can eat Earth. Oh boy. Well, if it eats Earth, we won't be alive, so we have to run away from the sun. Till now, it had been getting hotter every day and every day. So we don't have time left. Anyway, thanks for listening. I hope you enjoyed and learned new things, and goodbye.